So before we get too carried away with anything in question number 3, I want to make sure that we have an opportunity to finalize some key details in our observations on question number 2. So if at this point you've finished question number 2, this might be a good time to start looking at some big picture note taking, just so you can get a little bit more familiar with the vocabulary and the way that we talk about some of these expressions. Obviously, in your learning from home, you're not really going to be talking about these things. These things that I'm going to talk about in this next video are basically things that if we were in class, or if you were describing this in words to somebody in person, you'd be expected to articulate. But this is also important only because even if you're not going to personally say these things to somebody else, you'll hear me use this phrasing. And I want to make sure you understand what I'm saying and why I'm saying it, hence the quick opportunity to take a note break and make sure that we understand what's going on. As you probably recall, the expression that says x to the power of, I'm just using letter A as an example, x to the power of 4/3, that's what we call a rational exponent. Rational means fraction. Exponent refers to the fact that the fraction is an exponent or a power. But that is equivalent to that thing that we've been writing with the root symbol that I've officially been calling a radical, and the way that I would pronounce its equivalent expression. So if you want to read as I'm pointing to these things and notice the words that I'm using, we would call this radical expression the third root of x to the power of 4. Now you'll notice I wrote it in the order I said it, so I'll repeat that. This is called the third root of x to the power of 4. Now a third root is also known as a cube root. And the word root is actually used interchangeably with the word radical. So while you heard in the Desmos videos that this was called a radical expression, you can also think of the word radical as the word root. We just caution as math teachers against using the phrase square root, because this is not a square root. In fact, it's a cube root. A cube root refers to the fact that it has a little 3 there. Most people call it a third root. So the number attached to the leg of the radical or the root symbol dictates what kind of root it is. And I'll talk about that more in a moment when we deal with real numbers. Right now, I just want you to be familiar with the pronunciation. So we call this the third root of x to the power of 4. Now, if I was looking at question letter E, and if I was specifically looking at the 5/10 version of things, I would say that x to the power of 5/10, which I know can be reduced, but bear with me here, x to the power of 5/10 can be rewritten as the, notice my pronunciation here, 10th root of x to the power of 5. Now, it's also worth noting when we write the power here that there are actually a couple of different locations that the power could be. If I wrote it this way, as the 10th root of x to the power of 5, that's actually completely equivalent. Putting the 5 outside of the radical symbol or putting the 5 inside the radical attached to the x is actually the same either way. It doesn't actually matter which way you do it. So as long as the 5 is clearly an exponent, notice how it's lifted up as a superscript on the right hand side of the expression, just like all exponents are, that's all that matters. The exact placement of the 5 or the exponent doesn't really matter at all. So for example, if I go back to this one, the third root of x to the power of 4 could have just as easily been written like that. Sometimes, weirdly enough, you'll see things that look like the third root of x to the power of 4 with parentheses. Even that's okay, because notice the common thread here. The 4 is always an exponent. It's a superscript on the right-hand side of the expression, lifted up in the air. So however you write it is fine. It's just up to you. I just want you to know that those are all the same thing. Now, going back for a second to my 10th root example, remember how I pronounced it? The 10th root of x to the power of 5? That, of course, is not necessarily how some of us thought of it, because some of us thought of this problem not as 5/10 for a fraction, but as 1/2 for a fraction. And if you used the same rewriting idea, then rewriting this would say the second root, notice my phrasing, the second root of x to the power of 1. And then a little bit of common sense kicks in. 1 is just a power. We never really write powers of 1. Like 2 to the power of 1, we don't really write that. It's just 2. 10 to the power of 1 is just 10. 7 to the power of 1 is just 7. X to the power of 1 is just x. So most of the time you won't see a power of 1 written. It would just kind of appear like that. And for that matter, the second root doesn't always end up getting written as well. The root number actually is the number of times that that root counts for. So this is like saying we have a multiplication that is going to occur 2 times. By default, a square root does occur 2 times. So you won't always see that little 2 attached. If you're not sure what I mean by that, keep that thought in mind, but don't fixate on it too much. You'll see in a subsequent video what I mean when I'm talking about this idea of a second root. And all of a sudden you might see why the answer on the answer key looks like this. Because that actually is equivalent, even though it looks like everything is missing. It's curious, isn't it? So I'm going to leave that as a little bit of food for thought for now at the end of this last video, a bit of a cliffhanger, if you will. Why do you think that is? Why do you think the little 2 isn't there? And what do you think the significance of this outside number on the left, the number I've been calling the root number, might be? Now, that's meant to be a lingering question that I want you to think about throughout the lesson, not something that I need you to answer right now, just food for thought. If you feel like you get the hang of things, though, the next order of business is to try question number 3. Because in question number 3, the idea is to say, hey, this is a root expression or radical expression. How do I rewrite that with a fraction exponent? So it's almost the reverse of what we've been doing in these problems in number 2. They're giving you the radical and asking you to rewrite the fraction. So maybe this is easier. Maybe you could think of it as x to the power of, because we know that x is going to be the base. We know that the numerator is always the exponent, so there's the 5 over the root number, the number on the left, is always the denominator, so 4. This must be x to the power of 5 over 4. And if you can try to do some of these problems in number 3 with that pattern, I think you'll find it's an easy reversal of what we've just talked about. So take some time to make sure that this reciprocal relationship makes sense. Actually, I shouldn't say reciprocal, I just mean this sort of complementary relationship. Rational exponents can be rewritten as radicals, and radicals can be rewritten with rational exponents. So they definitely go back and forth interchangeably. Try some parts of question number 3, and then I'll clarify a couple of details about this that hopefully will help us make sense of it.